This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
This is Nate Black for Software Engineering Radio. My topic today is the Elixir programming language, and my guest is Saša Jurić, the author of Elixir in Action. Saša is a professional programmer with many years of experience writing desktop and web applications in various languages, including Elixir, Erlang, Ruby, JavaScript, C#, and C++. His blog, The Erlangelist, covers Erlang, Elixir, and other programming-related topics. Currently, he writes Elixir software for Aircloak. Saša, welcome to Software Engineering Radio.
Hi, Nate, and thank you for having me here.
We're going to cover a lot of ground today, so I wanted to give a brief roadmap for you and for our listeners. So the Elixir programming language. First, we're going to give a background and talk about where Elixir fits in with Erlang and how it might relate to other programming languages. And after we get the high level, I'd like to dive into details about the different features of the language and how certain things work in the language. And once we have those building blocks, we can move on to the conceptual things, such as like how does an Elixir programmer think about writing code and what are the big concepts of writing Elixir code. So first, Saša, let's talk about what is Elixir.
Okay, so that's quite a tough question. It is obviously a programming language. In theory, Elixir is a general purpose programming language, so it's Turing complete, and you can, of course, invoke various functions of the operating systems. But it's specialized, in my opinion, its sweet spot and its niche, so to speak, would be building software systems. And by software system, I mean any piece of software that is running on some server, and it has to run constantly and continuously, and it has to do many different things at any point in time. So like typical web server would be an example of a software system, but not just web server. It can also be like a database, for example, chatbots, and other kinds of things that we run on the backend side of things. So yeah, Elixir is like the language, in my opinion, suited and built for that particular challenge. And that's in particular because the language targets the Beam virtual machine, which is the virtual machine of the Erlang programming language. So Elixir is specifically compiled down to the Beam bytecode, and it doesn't try to hide that fact. It doesn't treat Beam as the implementation detail, and it doesn't treat Erlang as the implementation detail. And Erlang, and in particular Beam, is a runtime which is again built and fine-tuned for software systems, right? So it's a specialized runtime that makes it very, very special and unique. And it makes some decisions and trade-offs are made in the implementation, which are very well suited for software systems at the expense of other kinds of software, like maybe desktop applications or one-off tools.
You said that Elixir doesn't treat Erlang and the Beam virtual machine as an implementation detail. What did you mean by that?
So what I mean is that first of all, like you have types in Elixir, and the Elixir types are literally Erlang types. Then not many, but some things from the standard library which exist in Erlang are not wrapped in Elixir. So you literally call Erlang functions. And then there is the big piece of Erlang, which is called OTP. This is a framework, and this is a way how we structure our systems in Elixir and Erlang, and the OTP is absolutely not like hidden or abstracted away. We use OTP to build our systems both in Erlang and Elixir, and there's no some magical wrappers which try to hide that fact.
Okay, I think I understood. Let's see if I can summarize that correctly. So at the level of the language, Elixir can do some things with Erlang, like you can call an Erlang function, and perhaps it looks slightly different than when you call a function in Erlang, but it's the same thing as calling an Erlang function. Is that right?
Precisely. Yes, you can seamlessly call Erlang code, and the types of Erlang are also the types of Elixir, right? So there's no like some impedance mismatch or some magic in Elixir which it builds on top of Erlang.
Okay. Does the relationship also work in reverse? Like if I wrote some functions in Elixir, could I import them somehow in Erlang and call those functions in Erlang?
You can call Elixir code from Erlang. It's currently, like as far as I know, I didn't check for a while, it requires some improvisations. But as far as I know, there has been some work in progress to improve that. In fact, I mean, like when I first started with Elixir, it was about 5 years ago. I actually was using Elixir from the existing Erlang system, and with some trickery, it wasn't like completely automated, but I was able to combine the two and invoke Elixir code from Erlang. So one way or another, it's possible. And as far as I know, there is, of course, some work on the Erlang tooling side to improve that, to make that easier.
Okay, so it sounds like the relationship is, in principle, it can work both ways, but generally speaking, are people using it just in one way? Are they mostly calling the Erlang code and libraries from Elixir?
So my impression would be that in most cases, you call Erlang code from Elixir. You can also have, by the way, like when you have an Elixir project, which is called Mix project, the tool is called Mix. Mm-hmm. You can have both Elixir and Erlang sources in that project. We actually had that situation a few years ago. And you can easily then call Elixir code from Erlang. But in most cases, yes, I would say that people usually call Erlang code from Elixir, less often the other way around.
We had a few shows, I think, that in the past on Software Engineering Radio that I think might be relevant for our listeners to look at if they want more details about Erlang. We had episode 89, Joe Armstrong on Erlang, and he went into quite a bit of detail about the thinking behind that system. And we also had several shows on the Scala programming language and one on Akka. So that was episode 62, Scala, in which we talked a lot about functional programming and the details of Scala. So I think there might be relevant for listeners. And also the Akka system, which discusses an implementation in Java that is similar to the actor system or the actor model that is exposed by Erlang. So that's something maybe for our listeners to check out. And Sasha, I wanted to ask you if there is like a relationship or an analogy that we can draw with like the JVM and like the relationship between Java and a language like Scala that compiles to the Java bytecode. Is there a similarity there in the relationship with Elixir and Erlang?
Well, I gotta first say that I'm not super familiar with Java and Scala or like Clojure, for example. But my impression is that relationship between Elixir and Erlang is different than between, say, Java and, for example, Clojure. Maybe Clojure is even a better example.
Okay.
Because Elixir basically doesn't change semantics. Again, it doesn't really try to invent a new paradigm or build some kind of different way of completely different way, which isn't necessarily suited or envisioned when the runtime has been built, right? So when you have, for example, Clojure builds a functional programming language. The original language for JVM Java is not functional. It's like object-oriented language. And therefore, Clojure has to have some impedance mismatch, right? Simply by definition, because it's a completely different paradigm and it has completely different rules. With Erlang and Elixir, you don't have so much. They are very, semantically, I like to say that they are very close. There are some differences. I would say that they are, in my opinion, they are mostly minor differences. But for the most part, I like to think that Elixir and Erlang are almost like the same thing. I mean, obviously, they are different languages with different syntax, and beyond syntax, they have some different toolings in the language and around the language. But for the most part, I treat them as very similar languages. So that's one thing which is very special, I would say, in the relationship between Elixir and Erlang. If I would have to draw a comparison, maybe a better comparison could be like sort of C# and Visual Basic.net, although even that's not a fair comparison, but it's more like that. There's more similarity between Elixir and Erlang than, I would say, languages which I've seen on the JVM.
Okay, thanks for that clarification. Yeah, that makes sense. So because they're conceptually or in terms of their semantics, just the way that the language works.
So think about it like this. For example, as far as I've heard, like, again, I'm no expert.
Okay.
You have, like, for example, Clojure, or I think that I heard that in Clojure. You have like problems with stack traces. They can be hard to understand because of a lot of magic mapping behind the scenes.
Okay.
And when you see like a stack trace in Elixir, and it's going to contain some Elixir functions and some Erlang functions, and then maybe again some Elixir functions, and that's all very natural, because those are all ultimately, like Elixir programmer, you treat them as Elixir functions, and as Erlang programmer, you treat them as Erlang functions. They're the same concept.
Yeah, so it wouldn't be confusing to a person that is writing Elixir if they see something about Erlang in a stack trace.
It's just going to be another function in your stack trace. So like, imagine like you're calling the library. So you're going to see some functions which you obviously didn't write, but there's not going to be a lot of them, because there's not some magical layer of mapping from, say, one paradigm to a different paradigm, or those sort of things. So obviously you're going to have some functions. You always have some code which runs underneath you, but it's going to be, at least in my experience, it's fairly easy to understand. And it's just, you treat it as if it's Elixir.
Okay, thanks. So what are the advantages of the Elixir and Erlang? Why do people choose Elixir and Erlang over the competition?
That depends on many people. I've heard all sorts of stories. People tend to like one feature or some features. The concurrency is, for example, a very big story in Erlang and Elixir too. And I hope we're going to explore this today in more details. So that's definitely one thing. Some people just go because they want to try functional programming. Some people like it because it's fun. But in my personal opinion, and this is what I said at the beginning, and it's what I usually say, is that language and the runtime, the beam, they are focused. They're focused on a particular problem and challenge, and that challenge is building arbitrarily complex and scalable software systems. And in my opinion, if that's your challenge, then Elixir or Erlang are a great tool for the job. I would say arguably maybe even the best that you have available today.
What we know so far is that Erlang and Elixir are general purpose, but they have this sweet spot for concurrent systems that are really complex, and you're spinning out a lot of different things. And so we also understand the relationship between Elixir and Erlang a little bit, that they're very tightly connected. But what I'm wondering, what listeners may be wondering now, is what was the need for a new language, Elixir? Like, why did a new language need to be built to get the benefits of the Erlang runtime?
Yeah, this is a very good question. Obviously, I'm not the creator of Elixir, so I'm just gonna explain it from my own point of view. So Erlang is by all means great. Like, it has a great tradition, and it has been built. I think the implementation started, or the initial prototyping, as early as mid-80s or so, and they have used it since early 90s or mid-90s in production. So it's very well battle tested in various systems, large and diverse, and it has proven capacity to power complex and scalable systems. But arguably, I would say, at least I was using plain Erlang since 2010. So at the time when Elixir hasn't even begun to be developed. And there are things that are great about Erlang, and there are things that were maybe at the time not so great, or maybe stuck in some previous times, and I would say that those were not like super big issues, but it was a bit hard to start working on Erlang. So especially back then in 2010, there was much less literature. There was definitely Joe's book and maybe some other resources, but not as much as you have available today. The tooling was definitely not as good as it is today. So it was sometimes even hard to figure out what should I use to build my projects and to build a deliverable. And then I would say in particular for me, language. So I have to say that like Erlang as the language, it is very simple. It's one of the simplest languages I have ever seen. People tend to say that Erlang is complex, but that's not the case. The syntax is strange for most people because it's based on Prolog. But once you get past that syntax, it's a very simple language, very regular, not so much rules in the language. But I would say that this is at the same time the problem of Erlang because the language is simple. As a developer, I have to write much more code. So I don't have so much tools in the language to manage the complexity of the code. So that was like my personal impression. And in my opinion, Elixir strikes those problems, and it actually, I would like to say it's kind of shallow, but this is probably how I would convey it. It's like a more approachable Erlang. That's not all about Elixir, but it's definitely one thing which I feel, especially compared to the Erlang which I knew from like 8 years ago. So it's very easy to start with Elixir, and you can really make your projects pretty quickly. And you can then deepen your knowledge as you go along. You can refine it. A lot of effort has been invested into documentation and the tooling around the language. A lot of effort has been invested into making error messages user-friendly. So like when you see an error message, you actually get some pointers about what you should do to fix it. And then in the language itself, Elixir adds some features which allow us programmers to organize our code in a better way. Most notably, this is the meta-programming feature of Elixir or Elixir macros. But there are some other things in the language too. Some are like smaller pieces, some are maybe more bigger changes. But at the end of the day, as a developer who has used and has been using both languages for a couple of years, I personally feel that I can move more easily and I can work more easily with Elixir. But as a consequence, Elixir is definitely more complex language than Erlang itself.
I see. One thing you mentioned is that the tooling has improved, and you said that like the build process or the build tool had been introduced. Is that Mix or something else?
So Elixir always had a build tool, and it was always Mix since I remember. Like I started with Elixir in early 2013. It was before 1.0, and already Mix was a thing then. But Erlang, for example, when I started with Erlang in 2010, so Erlang currently has a tool which is called Rebar 3. Okay, and this is now the official building tool. But back then, I'm not really sure. Maybe there was Rebar, or maybe there even wasn't. I cannot completely remember. But at one point, when I found out about it, it still wasn't sure whether I should use it or not. So it wasn't official. It wasn't anything built from Ericsson or included in the release. There were some other tools like eMake or something like that. And people were using different sorts of things, and many people were just using plain make to build stuff. And then it was also not clear whether I should use these concepts of OTP to build my system or not. So things were like pretty vague for someone who came to Erlang and had no prior experience. And that's just my impression. Yeah, but as far as Elixir is concerned, Mix is definitely the tool which we use to start our projects, to build our projects, and to bring them on to deliverables, so deployable artifacts.
From your description, it sounds like a big part of the reason for people adopting Elixir might be the documentation. As you mentioned, like it just became clearer that here's how you can do things, here are the tools you can use, here are the patterns to follow, and just became clear what the right way to do things was. Is that a fair summary?
Well, I mean, again, people come from different reasons. I think that many people, for example, come just because Elixir superficially looks like Ruby. And I can tell you immediately that it looks like Ruby, but it's way closer to Erlang. Superficially, just it looks like Ruby. But for people, I guess it's okay. They have some sort of familiar thing, and they start with that. And then they discover along the way that they actually can read Erlang and that it's not at all hard. But what you said about documentation is really, what I would say, for example, this is really a good reason why you would want to come to Elixir. Although I have to say that Erlang has great reference documentation in my experience. So really, when I want to look something up in Erlang reference, it's always there. Like you have a lot of fine prints and details and everything is there. But as a tutorial, I personally didn't really find Erlang documentation so good. I would say that Elixir has, in my impression, better story here, especially when it comes to onboarding. Beyond just the documentation, you have getting started guides, the official ones on the language site. And I totally recommend starting with those. Like even as a book author, I tell to people, like, go to the Elixir sites, grab those getting started guides and start with that. And then if you really want to dive deeper, then you maybe want to read a book or two or more. But those guides are really very well written and very approachable.
Now, is a large part of the Erlang community migrating to Elixir from Erlang? Or is the story different? Is it like just the community is growing more because of Elixir, or what's the situation?
Yeah, well, I don't have official numbers. Obviously, I can only speak of my impression. So I would say that people who have been working with Erlang and are proficient with it, they mostly don't really migrate to Elixir, or maybe partially do some stuff in Elixir. But they have their own ways. They're happy. They know the material, and they're very familiar with Erlang. And there's really no reason for them to migrate then, right? We actually had this story at Aircloak. When I joined Aircloak about 4 years ago, there was already a lot of code base written in Erlang. Everybody was fluent in Erlang. And then even I didn't push and say, like, let's go to Elixir, because that would require a lot of rewrites, or you would otherwise have to maintain code in two different languages. And that's always more complicated than having just one language. However, I also definitely, as someone who has been in the community or using Erlang and following the communities since before Elixir existed, my impression is that definitely Elixir drew more people, a lot of people to this world of Beam ecosystem, as I like to call it. So both Erlang and Elixir, and there are other languages like Lisp for Erlang and Alpaca and so on. So I would definitely say, or I feel that Elixir definitely brings a lot of people to the whole ecosystem.
Now that we have an overview about Elixir and know high level what it is, let's talk a little bit more about the details. You mentioned a few interesting things already. You said that superficially Elixir looks a bit like Ruby. And I had a bit of that impression too, because when I look at the code, like the function definitions, they look like Ruby. I don't see any type annotations anywhere. So there's that aspect to it. But on the other hand, Elixir and Erlang are compiled. So is Elixir a statically typed or dynamically typed language?
No, Elixir is dynamically typed language, just like Erlang, which is, in my personal opinion, arguably the biggest downside of those languages. But it's very unlikely to be changed. I think that there are some experiments trying to do like maybe limited beam-facing languages which are typed, but for all intents and purposes, they are dynamically typed. However, they are, of course, strongly typed in the sense that types are well defined, and you don't have some magical implicit conversions of strings to integer or vice versa or something like that. And we have type annotations, which some people use, some people don't. They are definitely a far cry from a proper type system, but they can definitely help, at least in the documentation sense. And here at Aircloak, we certainly use those type annotations.
Now, the compiler can find certain types of errors, right? Like what type of, if I compile my program and there is an error, like what type of error would the compiler catch?
Well, it can catch not a lot as you would, of course, expect, since the languages are ultimately not statically typed. So it can catch like invoking an unknown function, or maybe if you have unused variable, then you're going to get a warning. So things like that, syntax error, of course, and like if you have some dead code which cannot really execute, sometimes that can be also reported. But of course, type errors cannot be caught by the compiler. As I've said, we have a system for type annotations. That one is built into Erlang, and then by extension Elixir. And we have some tools for that, which can then catch some kind of type errors, but not all of them, or definitely many of them are simply not caught by the compiler or in the build phase, in the tooling phase.
Now, there's a tool that called Dialyzer. I'm not sure, is that an Elixir tool or an Erlang tool, and what does it do?
That's exactly what I was talking about. So you have your code and you provide type specification. And what I mean by type specification, to make it more concrete, is you have a function, let's say it's called get, which takes an x and a y, and you can say function get takes an integer and takes a string, and it's going to return either a tuple where the first element is okay and the second element is float, or it's going to return an atom error. So that's like for an example. And then you can use Dialyzer, and Dialyzer can sometimes report that either types are not proper types, the types are not properly passed, or that the return value doesn't correspond to the specification. So it can find some sort of mismatches. And you don't even need to provide the specification, because Dialyzer uses it sort of in an informal way. It actually infers types on its own. So yes, it can find some errors about type, some kind of type errors, but there are many things that it cannot really detect, especially because of the concurrent nature of Erlang.
So maybe, for example, let's see if this is right. If I had a situation where I had a function that returned like an integer, and I try to do something that I can only do on a string, like let's say append a string to the return value of that function, even without type annotations, that's something that Dialyzer would find. Is that right?
That's something that Dialyzer might find. Yes.
Might find. Okay.
So yeah, I see those kind of errors sometimes, but to be honest, I didn't really, even though I use it frequently, I didn't really went into the implementation to find out the rules. So it definitely finds those kind of errors, and I've seen it like at least, say, on a weekly basis.
Okay.
And sometimes it misses those errors too. So it sort of depends on how exactly do you propagate parameters. And I gotta admit that I'm not completely certain myself about what will it detect and what it won't, but it definitely can find such kind of an error, like when you try to do a string manipulation on an integer, for example. Like I had this today, something similar to that.
Okay. I think this may have been discussed in Joe Armstrong's show. The way that I understood it was that if Dialyzer detects an error, it is guaranteed to be an error, but it's not guaranteed to find every error.
Exactly.
Of any particular type.
Yes, it's very conservative, and my experience is that it misses many of errors. So you're going to have to rely on tests for that, like in pretty much any sort of dynamically typed languages or late bound typed language. But when it detects something, then it's either a problem in the code or in the type specification, yes.
Okay. So at least we don't have to worry about false positive reports of errors. I have a list of sort of programming language features, but maybe it'd be better if I ask you, what do you think are the most important features, or like the most salient features of the language that kind of distinguish it from other programming languages?
So for me, by far, it's the concurrency model and the semantics it has and the guarantees it provides. That's like the selling point for Elixir and Erlang. Now, obviously, it's quite abstract. Like, you don't want to choose your language for concurrency. That's like, you have some end goal in mind. But the thing about concurrency in Elixir is that it's built for software systems. It's fine-tuned for that kind of challenge. And in a software system, you have a bunch of things that are running at any point in time. You handle a bunch of requests, you're doing some background jobs, periodic jobs, you're priming caches, invalidating caches, talking to external services, and so on and so forth. And I like to call all of these things activities in the system. You have like your request is one activity, my request is one activity. And maybe even as a part of a single request, maybe a bunch of other things are happening, like I'm talking to one database and communicating to a payment gateway and whatnot. And those can also be separate activities. And the Erlang and Elixir concurrency model, or the Beam concurrency model, if you will, because it's baked into the runtime, gives you this lightweight concurrency through processes. So these are not OS processes, these are lightweight, small concurrent things. And you can model all those multiple activities through these processes. And you can manage them and manipulate them, and you can run them concurrently. And this will, of course, give you scalability in both directions. And you can isolate failures and get all sorts of nice things. And it feels very natural. Because, as I said, I think about a lot of activities happening in the system, and the implementation really follows that. You have a bunch of activities running in the system, and there are explicit first-class things through these processes. So definitely concurrency, in my opinion, is by far the most important feature of both Elixir and Erlang and this whole ecosystem of Beam.
So it's interesting that you said that the most important feature of the language was the concurrency. And you said you called these different things that are happening concurrently in the system activities. And how is it that, like, what are the language primitives that allow you to create these activities, and how does that work?
Right. So it's fairly intuitive, although obviously it takes some time to get adapted to. You have this thing called process. And process, again, whenever I say the word process, I mean Beam process or Erlang process or Elixir process. That's the same thing, however we want to call it, but it's not an OS process. So let me give you a quick overview. When you start your system built in, for example, Elixir, you start a single operating system process. And in that OS process, you have a couple of threads running, by default, one per CPU that you have available. And these threads are called schedulers. And then we have these processes. These are the things that we create from our code. And you literally have, at the bottom of it all, you have a function called spawn. You invoke that function and you pass it a lambda, an anonymous function. And with that invocation, you have started a separate process, like a separate concurrent activity in the system. And the anonymous function that you passed to spawn is running in that separate thing. So you start it and you immediately move along. And now you have two processes running in the system. So that's the basic of it all. You can spawn a bunch of these processes as much as you wish. They are very cheap. They have like a few kilobytes of initial overhead for stack and heap, and then they grow if needed. They are completely separate things. I like to say that in Elixir or Erlang, concurrency is the same thing as total separation. They have nothing in common. They have their own stack, heap, their own flow of execution. They are even garbage collected separately, and they share no data. There is no shared data in Elixir. So instead, they can only communicate by passing themselves messages. And the message is an arbitrary piece of data, whatever term you can construct in the language. And you just send a message to one process, and the message is stored in the mailbox of that process, which can then pull it from the mailbox by using a language expression called receive. And then it pulls one message and it does something with it. So for those who are not familiar with this message passing, you can sort of think of it like a lightweight version or being similar to microservices, right? Like with microservices, you have operating system processes and they communicate by some messaging. For example, frequently it can be REST API or HTTP requests. And in Beam, you have these processes, these small, lightweight concurrent things, and they also communicate by sending messages. And that's primary and pretty much the only way how they can work together. So yeah, it's quite intuitive. And we use these processes a lot. As I said, they're very cheap. You can create like billions of them if you want to. And what we do is we really like to run different activities in separate processes. So for example, a typical example is when you have an HTTP server library or a framework, every single request is running in a separate process, right? So like you make a request, I make a request, we have two processes running in the system. And because these processes are completely isolated, it means that they can run concurrently, they can be running on multiple cores. Also, what processes have is they have a complete failure isolation. So if one process crashes due to an unhandled exception, all the other processes in the system are going to be running. There's no interruptions there. So therefore, if something wrong happens while handling my request, your request can still go on. Or we also have this preemptive scheduling. So for example, if my request ends up in an infinite CPU bound loop, something like equivalent of while true, if you will, your process can still run even on a single core system. So you get a lot of benefits by thinking in these separate activities and powering them by separate processes. And this is, to me, the core benefit of Beam facing languages. And this is, to me, the thing that distinguishes all these languages and the runtime from most of the things available today.
Okay, so it sounds like concurrency is the most important thing. Like of the various trade-offs that are being made, they're being made so that you can have this highly concurrent system and highly fault tolerant system.
Precisely.
You mentioned that there were three primitives that made up the concurrency model: spawn for creating a new process, which can be done frequently and is cheap, and then sending and receiving. And it sounds like sending and receiving are to a certain extent also cheap. Is that true?
Well, to an extent. So when you're sending, what you're really doing is you're copying the data into the heap or into the memory space of another process, of the receiver. So like if you had a large data which you're sending, say a list of billions of items, then it's obviously not going to be cheap, neither in terms of speed, neither in terms of memory. But it's the same again. Think of it as built-in microservices. When you're issuing an HTTP request, there is some cost, some price associated to it, right? And if you're issuing a huge payload, then obviously it's going to be a bigger price. In Beam, this is, of course, everything happens within a single OS process, or if you can also run distributed Beam, have a cluster of Erlang nodes or Elixir nodes, and then things happen over the wire. But when we talk about a single node system, then it happens in memory. In many cases, it's fast enough, especially if you optimize or if you pay attention to your protocol. So you don't want to be overly chatty. You don't want to send needless pieces of data to another process. And you want to design your protocol around these semantics and this property that data is being copied. There are, of course, some exceptions, some internal optimizations where the data is in fact not copied, but there are some reference counting mechanisms. But those are, I would say, mostly implementation details, which you mostly don't care about. So yeah, there is some cost associated to sending. Spawning is done within microseconds, I think. So it's pretty fast operation.
You brought up the fact that Erlang can also be run in a distributed cluster. And in that case, is there a difference when I send a message to a process that's on my machine or versus another machine? Or how does it work?
Yeah, so a particular interesting aspect of Erlang is that you're really distributed from the day one, even if you're running on a single machine. So in Erlang, distribution and concurrency is one and the same thing. That's a very interesting design decision. And so you're dealing with a lot of, or at least some of these challenges whenever you start working with Erlang or Elixir. Now, when we're talking about multiple nodes, what happens is, so let me backtrack a little bit. When you spawn a process, the result of the spawn invocation is a thing called PID, or process ID. This is a thing which uniquely identifies a process in the system. And in order to send a message to a process, then you use this PID. You invoke a function send, you pass it PID as the first argument, and the piece of data you're sending as the second argument. Now, a PID can identify a process in the same node, which means in the same operating system process, in the same Beam instance, but it can also identify a process running on some other node in a cluster. So you somehow connect multiple Beam instances into a single cluster, and then you can spawn processes on other nodes in the cluster, and you get a PID as the result, and then your programming model or your communication pattern is exactly the same. You don't really know whether that process is running in the same instance or on another instance. So in many parts, you are already distributed from the day one, and in many parts, the code doesn't change at all, whether you're distributed or not. Obviously, when you are actually using multiple nodes and some network, things are going to come through. So things are going to be slower because the data is then serialized and propagated over the network, and there are more chances of having net splits and things like that. But you can also have those situations even in a single node setting.
I want to talk more about macros because that's something that you brought up earlier, and I think it's pretty important to the language design of Elixir. But it's better to talk about pattern matching in the context of the distributed programming or concurrent programming. So in Elixir, when you receive a message, the way that it looks to me in the code is that it's almost like at the end of the function, you just write receive, and the process is then just waiting. It's kind of idle until it receives a message that matches one of the patterns that's in that receive statement. Perhaps we should explain what pattern matching is and how it works.
Yeah, the pattern matching is many things. It's used in many different contexts. Like at the simple example is it's destructuring of data. So you have a complex data. Let's say it's a tuple, for example, of 3 elements. It has foo, bar, and buzz. And then you can write an assignment expression or something which looks like an assignment expression. You write curly brace x, y, z, closed curly brace equals tuple, which is the 3-element tuple. And what happens is then x is going to have the value of foo, y is going to have the value of bar, and z is going to have the value of buzz. So that's a simple example of pattern matching. And it's quite expressive. You can do all sorts of deep nested matches, chained matches, and so on and so forth. And we use it in many different language expressions or constructs, if you will. So for example, one of them is function invocation or function definition. So you can specify a pattern as an argument to a function definition, and what happens then is when you invoke a function, the argument is matched against the pattern, and if the match is successful, then the function is invoked. If not, then you get an error. And you can have multiple clauses of the same function. So you define the function with the same name multiple times using different patterns, and then based on the arguments which are invoked, one or another clause is invoked, or you can have more than 2 clauses. So you can think of it like a switch, if you will. You sort of declaratively say, like, if this function is called with argument x being 1, then do this. And if it's called with x being the value of 2, then do that, and so on and so forth. In the context of the receive expression, receive is sort of like receive plus switch case, if you will. So you have the receive expression, and it basically says, I want to wait for a message. I want to pull one message from the queue if it's already there, or otherwise I'm going to wait for a message. So you write receive, and then you write the clauses. You list the patterns to the messages you're interested in, and you then, for every pattern, you specify the code which you want to run. So you can say, like, if I get a message, for example, get, then I'm going to take some value which I have, and I'm going to send it to the other side. And if the message is store, then I'm going to take the value which has been passed to me, and I'm going to store it somewhere in my own process in some kind of a state. So that will be like an example. So yeah, pattern matching is really used both in the functional aspect of Elixir as well as concurrent aspect when we're when we're awaiting messages and handling them.
So being used in the functional aspect of Elixir, did you mean in terms of functional programming and functional programming patterns, or just in terms of in how the functions are defined and how they're invoked?
Right. So yeah, I should definitely clarify this. So it's, I think, important to stress that Elixir and Erlang, they are basically two different paradigms in a single language. So they both have the functional programming aspect and the concurrent aspect, where concurrent is, in my opinion, definitely much more important. And I think even at some point Joe Armstrong said that we should stop calling Erlang a functional programming language. We should call it concurrency-oriented programming language, because that's what it's all about. So yeah, you have these two aspects. So you use concurrent programming to organize your runtime. Again, as I said, you want to run different activities in separate processes, and that's, you're organizing the things that are happening at your runtime, those different runtime activities. But functional is at the core of it all. So within a single process, Elixir is a functional programming language. It's not pure functional programming language, so you can have side effects, but it is functional in the sense that there are no classes and objects, and you have first-class functions, and data is immutable, so you cannot change data. And functional programming is then used to organize your code, to organize different concerns, and to model some domain, some piece of problem which doesn't involve concurrency. And yes, we definitely use pattern matching a lot, both in this functional aspect. So when I'm modeling some sort of domain or some sort of problem, or even solving like those fairly simple problems from advent of code, for example, then we use a lot of pattern matching to either decompose our data or to branch on different conditions, and so on and so forth. And it can all, in many cases, look very declarative in its nature. It's quite elegant. And in my experience, so I should maybe say that I came to Erlang from object-oriented languages, and I never did any functional programming before. And this pattern matching really is quite intuitive to get accustomed to it. It was one of the easier parts. So it's used in a functional aspect, and it's definitely, of course, used in a concurrent aspect of the language too.
You said that, in a sense, the case statement is like a switch statement. The part of the receive that has a pattern match will also contain a case statement, I believe. Is that right?
So it looks like this. You have receive in Elixir. You have receive, and then you have some pattern, arrow, and some code. Another pattern, arrow, and some code, and so on and so forth. So it's an expression, to be technically correct. We don't have statements, but yes. So receive is basically a receive and a branch, if you will. You can, of course, there is like catch all or match all pattern, which you just list the name of variable. So I would have like receive X, and then I'm receiving whatever comes first.
Right. And there are similar sorts of pattern matching, as you mentioned, in the function clauses as well as in the case statement. And I'm wondering if those are all in some way related.
Yes, that's all.
And if it has to, right.
Yeah, that's all pattern matching. So it really goes through every or many pores or many aspects of the language. You also have it in assignment. Even some tests are relying or can help you use pattern matching to test or verify some things. And they're used throughout many constructs and many pieces or parts of the language.
Another thing that you'd mentioned in our overview section was metaprogramming in Elixir and macros. Maybe this is a way for us to jump over to metaprogramming and macros, because I understood that some features in Elixir are actually built using the metaprogramming functionality of the language itself. Could you talk about that a bit?
Yes, that's quite interesting, because a lot of Elixir is built in Elixir itself, which includes some things like if expression, for example, or unless. Those are like Elixir macros. You can find the code and you can read the Elixir code of if. And that's very neat. I'd say beyond the plain academic curiosity, in that it makes it easier for people to contribute to the language, right? Because you don't really need to learn Erlang to contribute to Elixir. There's like a very small core of the language which is written in Erlang itself. Now, let's take a step back and talk a little bit about what it is. So Elixir metaprogramming allows you to run Elixir code during compilation time. You can write some functions and invoke them during compilation, and you can do some computations, like take some... a great example is, for example, how Elixir builds his string module, which deals with all sorts of Unicode characters. So it has a Unicode txt file or something like that, which has all the definitions of these characters. And the code of the string module, which is written in Elixir, plain Elixir, it reads that file during compilation, and then it somehow generates Elixir code based on that file. So that's one interesting example. Phoenix, the web framework, also is based a lot on metaprogramming, and it also builds sort of DSLs and allows us to build like more expressive code to route our requests throughout the system. So it's used in many sort of different parts, like of the language and of some frameworks as well. So the way it works is you can define, like as you are writing Elixir code, you're writing functions, those are plain functions, and you can also write a macro. And a macro is an Elixir code too, like you can use regular Elixir expressions, but the specific of macro is that it's invoked during compilation time. So what Elixir does is it first compiles, I'm going to simplify it a bit, but the way it works is it first compiles like this macro code, and then if there is some other piece of code invoking this macro, then it's going to invoke that macro in or during compilation at compile time. So and then the macro has the opportunity to inject some code into its calling site, and it can use Elixir to do that. So you have like a lot of expressiveness in how are you going to assemble the generated code. So yeah, that's like some sort of theory. It's all very, I would say that macros and metaprogramming in Elixir is arguably the most difficult part of the language, at least in my opinion. But it's also very powerful, and it can help you build some user-friendly DSLs, and it can help you make some compile time optimizations like the one which I mentioned with Unicode, where Elixir, literally when you're installing Elixir from source, or otherwise if you're taking pre-built binaries, this thing has been built once, and the bulk of the computation has happened at compilation time, and it just works for everyone. So that's also quite a nice benefit. And Phoenix makes some similar optimizations too, and it can bring down some decisions to compile time because of Elixir metaprogramming.
There's a lot there. I think perhaps metaprogramming and even Phoenix would be topics in their own right. Maybe we can talk a little bit more about Phoenix later, but I'd like to drill into metaprogramming a bit more. Now, at the top of a Elixir module, there's a module definition and a bunch of, and then within the outermost scope of a module, there are a bunch of functions. But usually at the top, I'll see a list of imports and requires. Mm-hmm. And I was wondering what was the difference between import and require? And I think that require has something to do with metaprogramming and macros.
They both sort of have to do. Require is definitely at the core of metaprogramming. So again, let's just clarify so that everyone can follow us. Elixir code consists of modules and functions. So you have functions, and those functions are organized in modules, which could be thought of as a kind of a namespace. So as I said, metaprogramming allows you to invoke some code during compilation time. So let's say I have module foo, and I want to invoke function from module bar at compilation time, or macro, if you will. So how does the compiler know that it needs to first compile bar and then foo? And the answer is that we do it with require. So require, if I want to invoke something from bar in foo at compilation time, not the runtime, but compilation time, then I say require bar. And this is like a hint to the compiler that it first has to compile bar and then bring it to be available in my own context of the module full. So that's require. Import goes beyond that. So import is require, plus it lexically imports everything that is public in bar. So when I say import bar, I implicitly require bar, and also whatever public function and macro exists in bar is going to be available as if it were my own internal function. So I invoke it without the module prefix. Okay, so that's like a convenience, if you will, that you don't have to, if you're frequently invoking some functions from another module, then you can import it. So you don't have to always have prefix bar dot this, bar dot that, and so on and so forth. Sorry, I can maybe add just one example. You have one special module called kernel in Elixir standard library. Kernel contains a bunch of functions like abs, for example, or absolute number, send, receive, and so on and so forth. All of this exists in the kernel module, and the kernel module is automatically, implicitly imported into every module that you define. If it wasn't the case, then you would have to write kernel.send, kernel.spawn, and so on and so forth. So that's a practical example of importing.
So in an Elixir program, I might see, okay, as a programmer, I'm looking at some implementation code in my own Elixir module or say my colleague's Elixir module, and I see a bunch of function invocations. The first thing I'd do is look within this module and see, okay, is this a function that is defined within my own module? Mm-hmm. And if it hadn't been defined there, it must have been imported.
Precisely.
Either implicitly because it's part of the kernel module, or I must have had an import statement at the top of the module.
Precisely. Yes, that's exactly the case.
Okay. On the other hand, if I wanted to use like an enum.sort function, I might have required enum, or do I need to even require it at all if I'm referring to it by its namespace?
So if you're using enum.sort at runtime, then you don't have to require it at all. And at compilation time, now I have to admit that I'm not really sure. You don't have to. I'm pretty sure that you don't have to even require it at compilation time because it's a language module. But if you had your own module, something which you wrote, like let's say my enum, for example, and I wanted to invoke some function from my enum during the compilation of my module, then I would have to require it.
I just want to clarify that the distinction here is between runtime and compile time. So if I wanted to invoke my enum.sort from a different module, so I'm in my own separate module and I want to invoke my enum.sort at runtime, I don't need to require or import anything. But if I wanted to invoke it at compile time, then I would need to require.
Precisely.
Okay. So then the distinction there is kind of like we have to know something about like what's happening at compile time versus what's happening at runtime.
So yeah, just to clarify, most of the time, like when you're writing regular function and you're writing the code, that's happening at runtime. That's your regular runtime. But then you can also write code outside of the function in the module body. And that code is being then invoked during compilation time as your module is being compiled. And you can then, what can you do there? You can compute some value, like some constant, and then you can use that constant from your function code. And what happens is that constant is computed during compilation, and it's baked into your compiled code. So you effectively move the computation to the compilation time. Does that make sense?
Yeah, that makes sense. This has some practical considerations too. I saw that on Twitter you're having a discussion about runtime configuration versus configuration that's baked into your application. Mm-hmm. So maybe this might be a situation where that comes into play. Yeah.
It's sort of related, yeah. It's sort of definitely related too, because the current configuration mechanism is also being invoked at compile time, which has its pros and cons. In my opinion, it's more cons than pros for that particular thing. And I'm personally arguing that you should define or derive or compute most of your configuration at runtime, because that gives you maximum flexibility. So you can, for example, invoke or grab your configuration from external storages such as OS environment, etcd, Vault, database, and so on and so forth, which is obviously something you cannot do at compile time, right? Because frequently the build machine is not the same as the machine where the system is running.
Right. So, so to maximize flexibility and configuration, you'd want to be able to define or change things at runtime versus compile time. So it sounds like, at the very least, it's something we have to be mindful of if we're writing Elixir code, to know what's happening at runtime versus compile time.
Well, for the most part, again, you don't. You write regular Elixir and you pretty much are running stuff at runtime. But there are cases when you have to be mindful. Yes. So I just don't want to scare people off. Like when you start with Elixir, you mostly don't deal with meta programming initially. You are maybe the user of it, but you're not really even aware that it's working like that. And you're just writing plain old regular runtime code. So, and then when you dive into that thing, when you want to do those compile time stuff, you have a lot of support from the language there, and it's going to then require you to be mindful about those things. But initially, you can go a really long way without doing meta programming. And many people will say, like Chris McCord, who is the author of the Phoenix framework and the author of the Elixir meta programming book, he will say that like the first rule of the meta programming club, don't use meta programming. So you really want to reserve it for those special cases where it can bring you a lot of benefits, but when it can help you a lot in many ways.
Got it. Maybe I need to ask one more question about require and import, because coming from other programming languages, I'd be tempted to use the import statement, like just if I want to, like, let's say I don't want to have to refer to the sort function by its namespace. Like, let's say I was using enum.sort. Would it be a good idea to do that? Or is like, I saw that there's also a alias keyword that I can use. Does that give me another way of referring to the sort method, or does it just let me change the namespace? Or can I just get it without the namespace if I don't want to care about, like, if it's enum.sort versus some other collection.sort?
Well, let's start with import first. So let's I would say it sort of depends on the personal tastes and preferences. What I tend to do, and like at Aircloak, what I think most of us are doing, we are mostly avoiding import in most cases, because import really makes things implicit and harder to track. So for the example you mentioned, you could import enum, and then you can just call sort. That sounds very neat because you don't have a lot of noise and clutter in the code. But the problem is then when you import a bunch of such modules, then it's really hard to track what are you actually invoking. So personally, for enum, I would never import it. Like never. Really, it's short 4 characters, and you write enum.sort, and then it's clear for everyone to see what's actually being invoked. The experience of reading the code is much more easier because things are explicitly stated. What are you invoking? Is it a private function? Is it a well-known function from the enum module? And in contrast, when I see just sort, my first thought would be that this is some internal sort which does things otherwise or somehow decorates the official one. And then I would have to browse to the code, and then I see, okay, it's not sort. Then I have to look through the imports, and then I can see, okay, it's the official sort. So it's a lot of distraction in the reading experience. Now we have the alias. So it's worth mentioning that in Elixir modules, you have this feeling of a hierarchy, because you can have a dot or a period character in the name. So you can have foo.bar.buzz, and this is a module name, and this is how we build some sort of informal hierarchies. It's not really like any sort of first-class hierarchy. There's no special relationship between, say, foo and foo.bar. There is just a character in the dot is just a character in the name. So the way we tend to organize Elixir code, you will quickly end up with like 3 level or 4 or 5 levels of hierarchy. So then calling foo.bar.buzz.some function can be really noisy, right? And this is where alias can help you, because alias allows you to shorten that name. It can also allow you to rename a module, but we mostly use it to shorten the module name. So you can state at the beginning of your module alias foo.bar.buzz, and then in the rest of the module, you can just write buzz instead of the full qualifier, if you will. So that allows you to give you some sort of a trade-off between still having an explicitly written module, but in a shorter form.
Okay, so it doesn't let us remove the module completely. So we just have buzz if buzz is the function name.
No, you can only do that with import.
Okay. So in summary, don't do it. Like don't use import just to shorten the name. It's not worth, I guess, the confusion, but alias is there if you want to get things down to just like the single namespace.
Yes, in most cases. There are always exceptions. So yeah, as I said, kernel is auto-imported, then Phoenix will import some stuff which really makes sort of sense, if you will. I don't know, with our code base, sometimes when we write a helper macro, which is used frequently, then we also import the module too, so we don't have to prefix it, because like we know within our team that what is that thing. But for the most part, I would say you wanna avoid import, and alias is something we frequently use to sort of make the code less noisier. And another nice benefit is that then you have listed some typical modules which are used at the top of your own module.
There are a lot of, I think Elixir is an interesting language, just even in the details. There are other things that we could talk about, like, for example, tail recursion and tail call optimization. That's a cool feature. We could talk more about immutability, and I think we already mentioned that. But I think if listeners want to know more about the details, I think your book does a really good job of talking about the building blocks of Elixir. So what I'd like to do now is move on towards more of the higher level concepts and talk about thinking like an Elixir programmer. So from that point of view, how do Elixir programmers think? How do you start designing a program, and what are that level building block?
Okay, that's quite a broad question. So I can obviously only say how I tend to approach the problems. And I'm going to refer back to what I said earlier, that you have two dimensions of the language. You have the functional Elixir and you have concurrent Elixir. It took me a while to figure it out, but these days I always first start by sort of premeditating and designing, whether in my mind or on a piece of paper, what things are functional aspects and what things are concurrent aspects. Then, because like in Elixir, you always have, you can think of like concurrent stuff, these processes, this concurrent programming are the things which are then managing the functional parts of your system. So concurrent is sort of like a higher level runtime organization, and functional is how you transform data and manipulate with it. Then I mostly tend to start with functional aspect first. So I flesh out, this is going to be like a single functional thing which runs within a single process. And I'm going to first model this functional thing, and then I'm going to work on a process structure. And I'm going to maybe have some processes around it. So to make this more concrete, I can give you an example of what I did like the last week. We had to implement some caching structure for some expensive computations. And it's a bit special because we want to do this caching immediately. So we start our systems and we have a bunch of database columns for which we want to compute some statistics. So for each column, we have to execute a couple of queries. And those are potentially expensive queries, and we don't want to run them on demand when we need the result of the computation. We want to compute this data when the system is started, so we have it readily available. So there is a notion of a queue, right? We have to form a queue of available database columns, and then one by one, we start issuing our queries. And whenever we compute something about the column, some statistic of it, we store it into internal cache, into some internal in-memory table. That's one part of the problem. And another part of the problem that in the middle of this caching, the database structure might change. And also in the middle of this caching, someone might actually need the result of a column, which is at the end of the queue. So we need to promote this to the top of the queue. And that's roughly the problem.
Yeah, so you have a couple things going on. So you're trying to build some data to display some in your application, presumably. But to get that data, you've got a number of different queries that have to individually be done and then assembled together into an answer. But in that time frame, some of the data backing those queries might change, and that needs to also be reflected in the answer.
Yes, that's the part of it. And then again, we are building statistics per each column in the database, and we are doing it one by one because we don't want to overload the database. But it might happen that as a user, you make some action, and we need to promote the column which is maybe at the end of the queue. We need to promote it to the top of the queue because we need that column to actually get you the result. So what I did there is, after first thinking about it, I decided to implement a functional data structure which gives me this kind of a queue. So it's a queue where I say, start me the queue with these items, and then I can invoke a function which says, these are now the new items of the queue. And it does an intersection. It discards the non-existent items, otherwise keeps the ones which are existing. And this functional data structure also gives me a priority feature. So I can say, I start the queue with the column 1, 2, and 3, and then I can say, bring me the column 3 to the top of the queue. It has to be like in a priority mode. Okay, so it's built in a purely functional way. It's an immutable data structure. It has the functions which instantiated and functions which can then do all this transformation on top of it. And this is what I did first, and I did tests for that. And it's like a structure which is tuned to our own needs of this particular caching queue. And then on top of that, I have built a process which then actually drives the thing. So it's a separate process which maintains this structure, and it receives messages from other processes when something changes in the database structure, and it receives messages when clients need to promote some column to the queue, and it uses this functional structure to then actually perform the job. So that's sort of a division of having a functional aspect first and then a process aspect first. And I'm keeping it simple here. Ultimately, we also have other processes which revolve around this queue and the caching structure. But this is the general idea, the way I like to think about it. I want to split what's functional and what's concurrent. And then I start usually with the functional part, because the functional part really means it's a sequential code. So functional is no longer divisible into multiple processes. And I write that code, I test it, and then I make concurrent processes which orchestrate around it. So it sounds a bit vague, but yeah, that's the idea.
Okay, I think we can use this example to talk about some other aspects of how you architect your system in Elixir. But let me just see if I can summarize a bit. The queue you're talking about in this case is just a data structure. We're not talking about like a message queue or something that usually we think of as active.
Yeah, it's a first in, first out data structure where we can promote some things to a high priority mode.
Okay, but then there is an active part of your system that's using that data structure to decide like how to prioritize and execute different.
Precisely.
Yes. Okay.
Precisely.
But I think it also illustrates something you said in your book about how Elixir can simplify an architecture, because if you design this system in another language ecosystem, you might have had a different moving parts, right? You might have actually used a message queue that was a separate message queuing system, or you might have actually had the cache as a separate layer in your architecture. Could you talk about that?
Exactly. So my impression is, and that's been like even before Elixir, when I used Erlang in my first project, smaller to medium projects, I'm almost positive that Elixir will lead to a simpler architecture, because it can give you a lot of these built-in solutions for things like keeping queues in memory caches, handling requests concurrently, and so on and so forth. And in many cases, you can, like especially simpler cases, you can just have your solution completely built with Elixir. Like a simple example is my blog. So my blog is powered by Phoenix. It's written in Elixir. It's a single project. It's a single process. It runs completely multi-core. It has some things beyond just serving articles. It has some internal analytics. It does registration with Let's Encrypt. That's also done in Elixir. I mean, I'm using CertBot as a tool, but the orchestration is done in Elixir. And I need exactly one operating system process. There's no Nginx or Apache or any other sort of reverse proxy involved. And it's a very simple solution. And such has been my experience, not only for that blog, but also for my first like more involved project, which I built in Erlang, and for the things that we do at Aircloak. And that has a lot of benefits. It brings a lot of benefits when your structure is more homogeneous, and when you don't need to run a bunch of different and multiple operating system processes powered by different technologies. So this obviously simplifies your operations. Instead of managing 5 or 6 or I don't know how many different processes and tools and technologies and components, you're managing maybe 1 or 2. It also means that there are less things to learn. Like, say, a junior developer comes to the project, they learn Elixir, and already they can touch every part of the system, which is not the case if you have like some key value third-party caches and message queues and reverse proxies and whatnot. Those are all separate pieces of technologies that need to be understood. Like if you learn Elixir, it will not help you to learn, say, Nginx configuration. It's a completely different kind of thing. So there's benefit in that. There's benefit in local development. I just start my project. There is the command how you start your mix project, and everything is running locally. I don't have to juggle with a whole bunch of these other things running in the system. There's a benefit in testing because everything is highly integrated and homogeneous. Then it's much easier to test everything. And there are a lot of benefits in all phases of software development, which primarily come from the fact that you have this powerful concurrency mechanism, and you can build a lot of stuff natively directly in Elixir or Erlang without needing to resort to third-party tools. Now, I want to mention or I want to stress that we use third-party tools. If the challenge is complex, we're going to reach for third-party tools. We are not afraid of that. We don't want to reinvent complex wheels. So I don't know, in my experience, very frequently we tend to use SQL databases, for example, or any other third-party database, which is a really mature product which you don't want to reinvent yourself. We sometimes use Nginx too. It's a good tool. It does the job, and sometimes it can help you. I don't know, people use etcd. I have used etcd at some point. People use Elixir with Kubernetes. So we definitely use those other things, but the threshold for stepping outside of our main technology is much higher. There's much less need for us to do that because we have built-in solutions. And if our problems are simple, like I want to manage some key value in memory, then I really don't need a third-party product. We have a great tooling directly in Elixir for that, for example. The same thing holds for message queue, for managing load, doing load regulation, rate limiting, pipeline parallelism, and all sorts of things. And this is really where the benefit, in my opinion, lies for Elixir and Erlang. The pitch line would be that your technology stack will be simpler, and that's going to make it easier for you to operate that system, to develop it, to test it, and to onboard new developers. And these are huge benefits, I would say, for any sort of project.
Crucially, the simple architecture is also something that scales, right? It's not just that it's simpler, but you can handle way more traffic. But
yes,
like, do you reach a certain point where the scale becomes an issue, and then how do you deal with it? Can you then start breaking things out into a more heterogeneous system? Does Elixir play well in a heterogeneous environment where you start to add like proxies or?
Elixir plays definitely very well with all these other technologies. So you have, for a bunch of them, you have like drivers written in Elixir. There are a couple of different ways how you can run or integrate foreign code, like code written in other languages in your Elixir-based system. So you can either run them in process or out process. So then you can use Elixir as a sort of controller plane, which orchestrates all these activities, most of which are still implemented in Elixir, and some of which are maybe running in other languages. For example, at Aircloak, we have some parts of our system written in Rust for some critical thing. And not a lot of parts, but we have some parts written in Rust, and that works natively for us. But we still start Elixir project, and then the Elixir project starts the Rust thing. Previously, in some previous incarnation of our system, like about 3 years ago, we were running Lua interpreter in C, and we were using that to power some Lua code. So you can definitely integrate in all sorts of ways. And as I said, people definitely put reverse proxies in front of Elixir when it actually makes sense. So by opting for Elixir, you are not confined to this world of Elixir or Erlang. You can step outside and use a lot of other things in many different ways when the need for that arises. Yeah.
Yeah, the part that you mentioned that I thought was interesting was that you can use it for orchestrating a lot of these different parts. So it's good for the concurrency and managing, I guess, hierarchies of different activities that are happening. Mm-hmm. But what is it not good for?
Well, I would say that Elixir is definitely, or Erlang are not really suited if you want to ship one-off tool to a bunch of different clients. Like say you're writing a command line tool, not for yourself or for your team, but for like a wider audience. It's going to be a huge pain to actually deploy that to a bunch of different unknown operating systems, and the deployable itself will be like very large. This is, for example, something where I think Go has a really great story in terms of this single deploy binary, which you can build for many different target platforms. Also, Elixir is very well it is known for Elixir and Erlang that they are not really super fast when it comes to raw processing, like number crunching, for example, doing some heavy computations. So if you're doing something like that, you're probably better off writing that critical piece of your system in, say, C, C++, or Rust, or some other language, and then integrate it into your Elixir system. I think that there were examples of, for example, video transcoding platforms written in Erlang, and obviously you don't want to re-implement the video manipulation yourself. You have a mature library like FFmpeg for that. Besides, beyond being just mature, the library is also very fast, and you will not be able to reach that same level of speed in native Elixir or Erlang. And people are using that, and then they're orchestrating these activities of their users, which are actually then, submitting videos, and they're orchestrating their queues in Elixir and Erlang. So the implementation of just the transcoding stuff is done in C, in the well-known existing library, and then you're orchestrating that code from your Elixir, for example.
Now, there are a couple of ways that you can do that. You said that you can do it either in process or out of process. What's the difference?
You can do it in process. You can run, for example, in process C, some other things too. I think also Rust can be executed in process. The problem with in process is that you can do all sorts of nasty things to the beam. You can break guarantees. Basically, by running for encoding process, the fundamental guarantees of beam are off the table. They are non-existent anymore. So if you have a seg fault, for example, in your for encode, like say in C, then you crash the entire beam instance, and then you lose the fault tolerance properties of Elixir and Erlang. Another example would be if your for encode ends up in the infinite loop, like CPU bound loop, it completely blocks the scheduler, and you can completely paralyze your system. So those are the problems of running in process. Obviously, the benefit is that there is no special marshalling of the data. So everything is in the same OS process. So it's going to be more performant. And therefore, those things are usually done for something which is really some small and limited pieces of functionality, like say if you want to implement a fast memory, a fast 2D matrix library for manipulation, or you want to maybe expose some machine learning functions which are implemented in some other libraries, then you want to run those things in process probably. For doing things outside of process, you pay a little bit of price in terms of communication overhead, because data has to be somehow serialized on one end, deserialized on another end, and vice versa. But you get fault tolerance, because how it works is you start this external OS process from Erlang or Elixir, and then you communicate with it as if it was Elixir process, as if it was the little beam process running in your system. And if it crashes, you don't crash, but you're going to know. So you get those fault tolerance semantics exactly the same as if you have them with native Elixir. So that's a big benefit there. And that approach is usually used when you have like a bigger chunk of work that you can do in the external things. So like I'm going to send it a message, and then it's going to maybe get the data from the database, and it's going to crunch that data. So it's going to do a lot of processing. This is a great candidate for running things outside of process, because the communication overhead is that not so big.
Okay, so there are some options, and you outlined some different, perhaps some thinking that we can apply, like into how we make the decision. It sounds like for the most part, it sounds very scary to, I guess, to import foreign code into Elixir, unless you really know what you're doing. There are a lot of considerations, it sounds like, into how you make the decision of how to use the foreign code. So I'll link to your blog post about foreign processes and how you make some of those decisions, and we'll refer to that in the show notes. So what are some examples of successful projects that are using Elixir?
Like just Elixir or Erlang, because you have, of course, a lot of projects using Erlang. WhatsApp is arguably the most famous reference there. My impression as far as Elixir is concerned, that the Bleacher report, they are the sport site, in the United States. I think they claim they are like the second largest. Maybe I hope I remembered it right. So they are, as far as I know, one of the biggest Elixir users. Otherwise, there are like tons of, other companies that are using it, smaller or large. I think that Pinterest was using it for something. Yeah, I would have to double check the whole list, but a bunch of people are using it for all sorts of things, yeah.
Why was it successful in those projects, in your opinion?
Well, people always, from what I gathered, like some other external reports, people, of course, always have a lot of praise for the concurrency. Again, many people came from different backgrounds, like from other languages where you actually had to fight the concurrency, and the same story holds for me too. And once you come to Erlang, that thing can really flow, and it can really help you build systems which are able to deal with larger volumes, but also systems which are more fault tolerant and somehow more stable in production. They sometimes even refuse to crash or refuse to completely terminate. Like in my experience, this sometimes happens even if I don't pay attention or pay particular attention to it. The system somehow survives. So I would say that this is like the biggest draw, the biggest thing that draws people to Elixir. I have seen that many people, in particular with Elixir, mentioned that it was quite easy to get started with it. You don't necessarily learn everything at once, but I think the approachability story in Elixir is really, really great, and people report that they are able to become productive within the first week, so they can write some code and move further, and then they refine their knowledge as they go along. So I think that's also a very important piece of the puzzle, and this is particularly where Elixir is very helpful.
Are people usually starting with the Phoenix framework when they are using Elixir in your experience, or are they just going with some other lower level functionality?
Well, I've seen cases of both, so it sort of depends, I guess, on the nature of how you want to approach the technology. I've seen many people starting with Phoenix, and I think it's a valid approach. You sort of get something going, something tangible and visible early in the game, and that's rewarding, right? And you see the feedback, and you see some progress and something concrete. On the other hand, there are people who like to just first start with the language, and they just want to ignore completely those other things like the framework and the other libraries, and they just want to start from the bottom and work their way until they get to those higher level things. I think that either approach is fine. It depends on your personal preferences. I would probably say that many people do come to Elixir through Phoenix or start with Phoenix directly, and that's all quite fine. There are excellent getting started guides for Phoenix too. So if you want to start like that, immediately want to start with web development, I would say go to the mentioned Elixir language guides, so you get some basic feeling of the language, and then go to the Phoenix getting started guides and just work your way through these tutorials, which are really great. And you will have something going, and you will be able to work to produce some code to be productive, and then you can refine your knowledge later on. I mean, at some point, probably you're going to have to look into some deeper resource, whether it's a book or a video or some series of blogs or whatnot, but you don't need to necessarily read all those volumes up front. Yeah, you can start pretty quickly and easily.
I want to call out a few resources for listeners that will be in the show notes. The first is on that topic of top-down with Phoenix versus bottom-up. I thought you had a very helpful and informative article about that very topic on your blog. So I'm going to put that in the show notes. And the other is that you had an architecture description for how you are using Elixir at Aircloak. And I think that might be informative for people as well. So I'll put that in the show notes too. I think the last topic that I had, I think is relevant for what you said about how Elixir provides fault tolerance. I want to try to understand the relationship between fault tolerance and scalability and how that works in Elixir.
Well, that's an interesting question. So I would definitely say that the mechanism for achieving both is the same in Elixir and Erlang. So we use processes or we use concurrency to get scalability and also to get fault tolerance. So the way it works is, again, I always have to come back to this mantra, which I'm calling run different things separately or run different activities in separate processes. And you want to have, like, in smaller systems, you can easily have like few thousands of them. And in larger systems, maybe hundreds of thousands or maybe even millions of them running in some extreme cases. So if you have a lot of processes, then you're giving a lot of potential to your virtual machine, to Beam, to spread that load across available cores. And obviously, then you're immediately vertically scalable. Like, say you're running on a 2-core machine and you're reaching, for example, say 90% of your capacity of your CPU resources. You take the system, you put it on a bigger box with more cores, and it just spreads its wings and literally scales because you're internally highly concurrent. So that's vertical scalability, and you get that out of the box. And I've actually had the cases of such scaling like immediately in my early Erlang days. Another thing that concurrency gives you is potential for horizontal scaling, because you can spread those processes around the cluster, right? So you can start with, say, 2 nodes or 3 nodes and maybe add another node and have some library which actually does the spreading of those things, and you can scale horizontally. This story is not so seamless, so there's definitely room for improvement in terms of higher level libraries which make these things easier, but it's again rooted in concurrency. And then finally we come to fault tolerance, and fault tolerance really works well with and it's powered by this concurrency because as I mentioned, a failure of a single process does not disturb anyone in the system, right? It works like an OS process. A process crashes, there is like a division by zero, square root of -1, or some kind of an error like that. You get an exception, a process crashes, but everything else keeps running without any interruptions. Because there is no shared memory, the crashing thing left no garbage behind for other processes to be corrupted. And finally, the third piece of the puzzle is that a crash, even though it's not an abrupt event, it's also not a silent event. Any other process in the system can be notified about a crash of any process in the form of a message. So I could get a message, like if I'm a process, I get a message, process foo has terminated because of the reason bar. And then I know what has happened, and then I make this decision. I can make some decision, like maybe I'm going to start another foo. This is called also the supervisor pattern, where the system heals itself. Or maybe I'm going to take the role of the foo myself when it's down. Or maybe I'm going to take myself down because my work doesn't make sense if foo is not running. So these are quite simple primitives. We have some higher level wrappers on top of this, and they allow you to structure your program in a way where you separate individual actions and you separate crashes. Like if something happens and it's in one process, it will not disturb any other process. So this sort of guides your decisions about how to split things across processes. Like a typical example is, let's get back to the cache story. You're populating a cache from the database and you're managing a key value cache in some process. You're going to have 2 processes at least. One, which actually reads stuff from the database, and another process which keeps this stuff in memory. The reason why you have two is because if the reader crashes, which it might because it maybe talks to an external database, so there's networking and that's always flaky and can fail, you can still, so if that database reading fails, you still have the process which keeps that data in memory. It's still there intact, right? So you have separated failures. So that's an example of how you can think in fault tolerance with concurrency.
Okay, so the thing that's trying to retrieve data from the cache, if it crashed, it wouldn't also cause the entire cache to crash, for example.
Exactly, yeah. That's a very simple example. Yeah, you can have like more elaborate examples. When I had one example when I was reading from a TCP connection, I had to parse the data and then do something with it, and it involved a bunch of processes. Like I had just one process which was just reading. It established a TCP connection. It was just reading bytes and forwarded them to another process. And what you get by this is whatever else fails down the line, you still get to keep your connection open. And then I had like a pipeline of 5 to 10 processes which would do these micro phases of the whole pipeline. And the fault tolerance of it was brilliant. I was like super surprised how easy it was to get it and how stable the program then was. Because you get whatever fails, it's a micro failure. If you're running thousands of things or millions of things, then one failure really doesn't make all that big of a difference in the grand scheme of things. Most of your system is running, and this is what you want to have in a software system because you want to provide service to the most of your users most of the time, right? That's the philosophy.
I see. So the philosophy of Erlang of letting things crash when they have errors and restarting carries over into Elixir. And because you just let those failures happen, you try to handle it, you end up with overall a more stability. And
yes.
Yeah, you don't accumulate errors.
Right. So let it crash is it's sometimes wrongly. I mean, it's a catchy term, but it's sometimes maybe misunderstood. Let it crash is really what it really means. Is it means fails fast. So when something is off in your system, like some preconditions are not satisfied or whatnot, you're going to raise and you're going to just let the thing crash. But you're not going to let everything crash. The idea is to split your system into these small micro pieces, which you can then let crash because no one is, in fact, too big to fail. So that's a very important piece of the puzzle.
Got it. Okay, thanks for that clarification. So you said that Erlang allows you to have any process be notified if another process fails. And you said that this is part of the supervisor pattern. I've seen some in Elixir code, I've seen some instances where you have specified a supervisor and different supervisor strategy. So is this the higher level wrapper that you're talking about?
Right. The supervisor is definitely a higher level thing because it's implemented in plain Erlang and you could re-implement it yourself in plain Elixir, which is like a nice exercise. And yes, the supervisor, what it does is you basically tell it to start one or more processes, and it asks the runtime to be notified if those child processes terminate, no matter why they terminate. So then the supervisor gets a message like child foo has terminated because of a reason bar, and then it will do something. It can either restart the child, or it can restart all the children, or it can restart just younger children, so the one which are depending on that child. This is what you specified with supervision strategy, like how it will handle the case of a child which needs to be restarted.
I think we covered the basic building blocks, and if people want to know more, I think your book is a great resource, Elixir in Action. And maybe now is a good opportunity for us to talk about how people can find out more about you, your blog, your book, and any resources and dates that you wanted to mention.
Okay.
So your book has been in Manning's early access program, and I think it's either being released now or it's going to be released soon. Is that right?
It's in the production phase, yes. So it's going to be released, but I have no clue about the dates. So things don't move super fast with Manning. Within, I hope, 2 or 3 months.
Okay, so possibly within the window of when this podcast is published, but it's available for early access now, and I was able to read it through Manning's early access program and just get the book online. So yeah, that's, I think, a resource that I found to be really, really informative. And then of course your blog, your Erlangelist, and I'll put that in the show notes too. Was there anything else you wanted to mention?
Well, like in spoken word, maybe no. I can send you a bunch of links. I have compiled some, and some which came to mind as we were doing this talk. So I could compile the list and just send you the links, which you can include in the show notes. I think that's fine.
Okay, then Sasha, it's been great having you on the show. And for Software Engineering Radio, this has been Nate Black. Thanks for listening.
Thank you for having me here. It was a pleasure.
My pleasure. Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.